Hello, my name is Samuel Choi, and this is my CS1 2020 Intermediate in Embedded Systems final project. What I've created here is a wireless USART communication project where we have two microcontrollers. We have a leader one and then a follower one that are communicating serially by USART, but instead of using a physical wire to connect them, we are using a laser to carry that information. The majority of this is done is using by a circuit. Specifically on the leader side, I have a CMOS inverter which inverts the USART signal, which is usually high, and then it pulls it down to low when it wants to send information. So instead of having the laser constantly on and possibly burning it out, I have inverted that signal so it is at low, and then it pulls it high when it wants to send information. On the follower side, I have a voltage divider that uses the photoresistor as one of the resistors in the voltage divider. So what this does is, when the laser does hit the photoresistor, it modifies that voltage, or the resistance, my bad. It modifies that resistance and allows for either more voltage or less voltage to go through. That input voltage is then sent to a Schmitt trigger, which acts as somewhat of an ADC. It takes that analog voltage and it generates a clean square wave. So the purpose of that is to get rid of noisiness. Depending on the the rising edge and falling edge of the laser, there can be some issues with noise regarding possible spikes or valleys in the incoming signal. So this negates that completely, and then it gives a clean signal so that it ensures that the information is going to be transmitted properly. So just to demonstrate, if we break the line of sight that the laser is using, we can see that the leader is still transmitting data by the LEDs moving, but the follower has stopped receiving any data, so it's not outputting anything. But once the laser communication is resumed, you can see that the follower is now receiving data again, and it is working properly. I will get into more detail right now regarding what that inverter circuit looks like and what the Schmitt trigger looks like. Okay, so if we take a look at the leader part of this project, we can see the microcontroller right here. That is the ATmega 1284 microprocessor. The green wire right here is that's what's connected to the transmit pin of this leader microcontroller. That then leads into this MOSFET array, the CMOS inverter, where it takes in that signal that I said, the USART signal. It's idle when it's high, and then when it's sending data, it gets pulled down. So what this does is, instead of burning out the laser and constantly staying on, it takes that USART signal and it inverts it. It's a pretty simple circuit. All it does is prevents the laser from burning out. And what this transistor right here, this transistor is a 2N2222A, that acts as a switch, which once that signal, the high signal is sent, it activates that laser. Okay, so now that we're moving on to the follower side, what we see here is the circuitry. These four resistors, or these three resistors and this photoresistor, what they act as a voltage divider. So the power coming into this via these two wires is coming in at 5 volts, but the Schmitt trigger, the trigger that switches and keeps it at a constant square wave, only works between like a threshold voltage of 2.5 volts and around 2.2 volts. So what this does is, this first voltage divider, it steps it down to 2 volts, and then the most important part is this. So the laser is hitting the photoresistor right now, which changes the resistance and allows for that voltage to go back and forth between that threshold voltage of 2.5 and 2.4. Basically, you can think of it as some sort of a potentiometer where the voltage is adjustable because that resistance is changing. So the output of this second voltage divider is going into this Schmitt trigger. The Schmitt trigger consists of these two transistors. These transistors are 2N3904 PNP transistors, and what they act as, they basically allow for the reference voltage, which in this case is going to be that 2.5 volts, to be compared to the threshold voltage of 2.5, which is going to be set by using different resistors to the power line. So what this does is, once it receives that information and triggers that threshold voltage to be same as the input voltage, it sends the signal that it was receiving from the USAR, which is carried through the laser, and it goes through these blue wires into the receiving pin of this one. So just to reiterate, What this does is the voltage dividers act as a trigger for that threshold. Once that threshold is achieved, the information is then allowed to be sent to the follower. So if we cut off this laser again, we'll see that it has stopped communicating because the laser is not activating the second voltage divider, which is not allowing for that threshold voltage to occur. Once it's resumed though, the circuit does function properly and it is receiving the information again. And that concludes my video on my laser USART project. Information regarding the Schmidt trigger and the transmitter circuit, including schematic diagrams, can be found in the link in the description. And thank you for watching.